أهلا ومرحبا بكم جميعا في ويبينار كيف نحارب المعلومات الخاطئة والمضللة المتعلقة بالمناخ. سعداء ان انتم معانا اليوم. انا اسمي هدى عثمان وانا عضو بهيئة التحرير في أريج، وسعيدة ان ادير هذه الجلسة اليوم. هيكون معانا ضيفين متخصصين في مجال محاربة المعلومات العلمية من شبكة ساينس فيدباك. معانا اليوم كيتي فالنتاين وإيمانويل فينسون، وهو من شبكة ساينس فيدباك، وهي شبكة من العلماء العالميين اللي بيفحصوا الأخبار والتغطيات الإعلامية ويفرقوا ما بين المعلومات الخاطئة والمعلومات الصحيحة. والهدف هو أن القارئ أو المشاهد يكون واثق في المعلومات اللي بيحصل عليها المعلومات العلمية. أهلا بكم بكيتي أنا مش عارفة لو كنتوا سامعيني ولا لا، لأني ما كنتش حاطة لسه الترجمة. أرجو أن الجميع يكون كان سامعني. يجب أن انتوا تختاروا، عشان طبعا كيتي ومانويل هيتكلموا باللغة الإنجليزية، فأرجو من الجميع دلوقتي أن هو ينزل تحت مطرح ما مكتوب interpretation ويختار اللغة العربية عشان خاطر تقدروا تستمعوا للويبينار باللغة العربية. تمام؟ اوكي، شايفه ان الجميع بيقول انه سامعين كويس وكل شيء ماشي كويس. طيب، احب ان انا ارحب، هنتقل للغه الانجليزيه عشان ارحب بكيتي وبايمانويل. Katie and Emmanuel, thank you so much for joining us today. This is a super important topic that we are interested to discuss and to get to know some information from you and some tips for our participants here today. So if we can start by you introducing yourselves, and then you can go ahead with your presentations. Maybe we can start with Emmanuel.
Yes, so hi everybody. Thank you very much for the invitation. I'm happy to be here today to share some thoughts about how we work at Science Feedback. So a little bit about my background. So I'm a climate scientist by training. I used to study hurricanes and how the hurricanes extract energy from the ocean and how in return they mix the ocean. So purely physical science. And then when I was at MIT in the US as a climate scientist, I started realizing that there was a lot of misinformation about climate change in the media, in the US media. And so that is when I started with a couple of colleagues, other climate scientists, the project called Climate Feedback. So this project, the ambition was to bring the scientists themselves to be in a position to correct misinformation or help the internet users find out whether what they see, what they hear on the web is actually consistent with the science. So that is a quick background about myself, and I'll let Katie introduce herself now.
Hi everyone, I'm Katie. I'm the climate editor at Science Feedback, and I'll just actually change to the next slide. Oops, sorry about that. And yeah, so my role at Science Feedback, I've been working there for about 3/4 of a year, so I'm a little bit newer than Emmanuel is. I do, a lot of the climate fact checking for Science Feedback. I have a background in journalism and science communications. So before this position, I was working as a communications specialist at NOAA, which is a United States agency that tackles climate, weather, ocean science. So I'm very familiar with kind of the climate realm. And before that, I was doing climate and environmental journalism. So yeah, really happy to be here. And yeah, if that's it, we can actually just get started on our presentation.
Absolutely, go ahead. Thank you so much, Emmanuel and Katie.
Perfect. Yeah, thanks so much. And we'll be stopping kind of periodically throughout the presentation. So if you guys do have questions, kind of write them down. We've got a few different kind of sections to this presentation, so we'll stop periodically and let you guys ask questions. We wanted to start with just a quick introduction to climate science. I know that a lot of you don't have a strong background in climate science. That's totally okay. That's kind of why you're here. And for those of you that do have more of a background in climate science, I hope this will just kind of serve as a refresher. But we have just gonna move this a little bit. We have a definition here of climate change from NASA, the US Space Agency. So I'll just read it out loud. Climate change is a long-term change in the average weather patterns that has come to define Earth's local, regional, and global climates. These changes have a broad range of observed effects that are synonymous with the term. And the key here, I kind of bolded a few key kind of areas in this quote. The key here is long-term change. So climate change is really measured on the decadal scale. When you are looking at, maybe a change in the average weather for about 5 years, that's not really climate change. That's kind of just like an anomaly. But when you're looking at, weather patterns are consistently changing over several decades, that's what we refer to as climate change. And usually scientists, when they refer to our most recent climate change, they're referring to climate change from the pre-industrial period. So about kind of the late 1800s onwards. And then the kind of second thing I wanted to pull out from this definition is climate change has a broad range of observed effects. So as the Earth warms, and we'll get into this a little bit later, but as the Earth warms, it has a very broad range of observed effects on the climate system. It's not just the Earth is getting warmer, so everywhere is getting warmer. It's the Earth is getting warmer, so precipitation changes from place to place. The incidence of heat waves might go up and down from place to place. There's also impacts on the ocean. So yeah, it's just a very kind of broad range of effects. And like I said, we'll kind of get into those a little later. And then the graph here is the carbon dioxide concentration measured at the Mauna Loa Observatory in Hawaii. This observatory is really good for scientists monitoring carbon dioxide concentrations because it's very remote. It's on an island on a volcano in the middle of the Pacific Ocean. So it's not impacted by like local vegetation or local pollution. It's a very kind of like pure atmosphere, so they can measure really how much. Oh yeah, sorry about that. Yes. Yeah, no worries. I do tend to speak quickly, so I'll slow it down. Yeah. So basically at Mauna Loa, scientists are tracking carbon dioxide concentrations. They've been doing so since the late 1950s. And you can see from this graph that carbon dioxide concentrations from the late 1950s have grown from about 315 parts per million, and parts per million is just how we measure carbon dioxide in the atmosphere, to now today, which we're around 415, we're over 410 parts per million. And this is important because, as we will discuss in the next few slides, carbon dioxide is the main driver of climate change worldwide. Carbon dioxide is a greenhouse gas. There's a couple other greenhouse gases that are drivers, but carbon dioxide is kind of the main one. So this slide just gives a very kind of easy introduction to the greenhouse effect. And the greenhouse effect is really what is causing climate change right now. The greenhouse effect as a whole is a good thing. It is why Earth is livable. We have this atmosphere that protects us. We have a livable climate because of that. But because humans are emitting more greenhouse gases into the atmosphere, including carbon dioxide, it's creating kind of a runaway greenhouse effect. It's creating kind of a, I guess, enhanced greenhouse effect. So basically, as you can see here, the excess carbon dioxide and greenhouse gases in the atmosphere serve to trap more of the sun's heat on the planet instead of that sun's heat radiating out into space. So that just serves to warm the planet more than kind of it otherwise would be warming. And if you guys have any questions about any of this science, we'll kind of pause after this main climate introduction and you guys can ask questions. So this slide just takes a look at sort of the other greenhouse gases that lead to climate change, essentially. So as you can see from this pie graph in the right-hand side of the slide, carbon dioxide is the main driver of climate change. You can see 76% is really, of the carbon dioxide emitted, is really going towards warming the planet. Or 76, carbon dioxide makes up 76% of kind of the greenhouse gases that warm the planet. There are some other ones. So methane often comes from things like agriculture, things like natural gas. When there's mining of natural gas, there's off-gassing of methane. That's kind of the next big one. And then nitrous oxide and fluorinated gases, they're kind of smaller. Nitrous oxide often comes from land use type situations, and fluorinated gases are used in refrigerants, but they're kind of smaller pieces of the pie. You can see on the left, each of these greenhouse gases have a different global warming potential. So that's basically how much each gas traps heat in the atmosphere. So you can see here that carbon dioxide actually has a lower global warming potential. It traps less heat than the other three greenhouse gases, which is kind of speaks to how much carbon dioxide I think we're putting out into the atmosphere, because it actually traps less heat, but it is the main driver of climate change. Methane traps a little bit more heat. Methane is also, to add, I guess, a little more complexity to this, methane is also a little bit shorter lived. So carbon dioxide sticks around the atmosphere longer than methane. And then nitrous oxide and fluorinated gases, they trap more heat than even carbon dioxide and methane do. But really the main takeaway from this is humans are releasing greenhouse gases. I mentioned kind of where methane and the other ones come from, but I didn't actually mention carbon dioxide. Carbon dioxide is released by industry, burning fossil fuels, essentially, transportation, like anytime we're, driving our cars, that type of thing. A lot of different things release greenhouse, or at least carbon dioxide, but I would say the big ones are kind of industry and just transportation. Okay, and because of all of this greenhouse gases emitted into the atmosphere, the Earth is warming. So as you can see in this, on this graph, since 1880, since scientists kind of started tracking this, you can see that the temperature has been increasing from the average. So especially right around kind of 1950, you can see that the temperatures are really starting to go up. And since about, the late 1970s, we've only had kind of warmer than average years. So that kind of speaks to just how much Earth is warming. So the temperature has actually risen 0.8 degrees Celsius per decade since 1880. And actually recently, it's even more than that. So it's kind of speeding up, as you can see. And Earth is warmer now than it has been in 125. Oh, sorry about that. Okay. So sorry. Okay. So I'll just kind of repeat the bit about the figures. So basically the takeaway from the figure is we're seeing much higher than average temperatures, especially more recently. The warming is just kind of sped up in recent decades. And I'll also mention that Earth is warmer now than it has been in 125,000 years. We will get into a little bit just soon in the slides about how scientists know that, essentially how they know what the temperatures were 125,000 years ago. But just kind of the takeaway is the Earth is warming, and it's warming even faster in recent decades than it was in previous decades. So yeah. Okay, so I wanted to touch briefly on the difference between weather and climate, because that's kind of a big question we get when people start looking into climate change, what the difference is. I have this quote here: climate is what you expect, weather is what you get. Essentially, weather is short-term, climate is long-term. So if you look at your kind of 7-day weather forecast, that's going to be weather. It's going to be just what to expect in the next few days, maybe a week. climate is really on the, year to decade to even century scale. So, saying something like, we know the United States Southeast region is hot and humid in summer, that's climate. Weather might be just the various, differences in weather during that summer region. So it could be really rainy one day, it could be really sunny the next day. It's just going to be varied. But so the really main takeaway is that climate is a long-term issue and weather is short-term. I also wanted to touch very briefly on climate change versus global warming. Both of these words or these terms are really kind of used interchangeably at this point. Global warming tends to be a little bit more outdated. You'll see climate change more often now, but takeaway is you can use either, it's totally fine. Global warming tends to refer to just the rise in global temperatures that we've already talked about. So because of greenhouse gas emissions, the Earth is warming as a whole. Climate change, on the other hand, tends to refer to just the differences in climate that warming is causing. So as I said, just because the whole globe is warming does not mean that every single part of the globe is going to be becoming hotter. It's a little bit hard to kind of wrap your head around when you're first starting, but essentially that warming just causes differences in climate around the globe just because of the various things that go into weather and climate, kind of how they shake out. And so, yeah, basically, as to kind of sum up, as the Earth's average temperature warms, it causes those changes in climate. But again, you can use either term. Don't be confused if you see either or. So yeah, briefly, I wanted to show a few graphics that kind of illustrate this trend of climate change. This one is, it shows change in temperature in Fahrenheit per decade from 1990 to 2020. So that's the last 3 decades. One thing to point out is that the Middle East is warming very rapidly. We'll get into this a little bit later, but parts of the Middle East are actually warming, 2 to even 7 times faster than the rest of the planet. So that's obviously really important for you guys, as you're starting to think about climate fact checking. I'll also just touch very briefly on the fact that the Arctic is warming. Usually, I think scientists say twice as fast as the rest of the planet as well. That's due to a couple different kind of scientific factors that we don't have to get into, but Arctic warming does kind of cause like a couple different kind of cascading effects throughout the globe. And this, so kind of, I mentioned Arctic warming. One of the big kind of impacts of Arctic warming is changes in Arctic sea ice. So as you can see from this graph, Arctic sea ice has been on a downward trend since 1980. That changes kind of ocean circulation patterns. It kind of can change kind of a wide variety of things. But I wanted to include this in here because Arctic sea ice does tend to be something, Arctic and Antarctic sea ice does tend to be something that climate, misinformation is circulated about from time to time. You'll see a lot of claims about, actually Arctic sea ice has grown or actually Antarctic sea ice has grown. And so kind of understanding the science behind that is can be helpful. And then, so another really big impact of climate change is rise in global sea level. So this graph just shows that since 1880, you've got really just an upward trend in global sea level rise. That happens for 2 reasons. So one is the melting of glaciers. So, as temperatures get higher, glaciers melt and that water goes into the ocean and it causes a rise in sea level. The other factor is ocean, it's thermal expansion. So essentially, as the ocean warms, it actually expands. So that also causes a rise in sea level. There's 2 different colors on this graph. It just is different data sets. The black one is a little bit more recent. Yeah, and I think I'll stop here. Emmanuel's going to chat next about how we know climate change is human caused, but I wanted to stop and see if anyone had any questions about. I know that was a lot of science, and I know I spoke a little fast, so if you have any questions for Emmanuel or I, please let us know.
Thank you, Katie, for this introduction. I feel it's important to get, some of the basics before we get started. We do have some questions. There are 2 questions in English, so I'm going to start with those. It's quite long, so bear with me. But the question is from Abdullah Omar, and his question is: do you believe that electricity powers from natural characteristics stops these kind of gases, especially carbon? For example, depending on electric cars, what are the solutions to keep the greenhouse safe? Any suggestions? As you know, it's kind of dangerous for human beings. To be honest, the Middle East is warmer. Iraq's temperature crosses 50 degrees Celsius. What are the expected fake news? So if I'm trying to understand some of the questions in this question is, what can be done to stop the gases, especially carbon? And how, if you can touch on, the fake news related to the Middle East.
Yeah, great.
Go ahead. Okay, just for the electricity part. So as Katie explained, the main origin of the greenhouse gases that cause climate change is the burning of oil and gas and coal. So indeed, switching to electricity as a power source, and if that electricity comes from solar or nuclear or wind source of energy, these are sources of energy that do not emit as much carbon dioxide, for instance. So yes, switching to electricity is indeed one of the main solutions that can decrease the amount of climate change that humans are causing. Then for the other part of the question, which is what kind of fake news you can expect. I mean, this is going to be addressed in the rest of the presentation. So I think it's better if we keep talking later about this, the kind of, the most common fake news. We have that in the next slide.
Sounds good. Thank you, Emmanuel. Another question. Thanks, Katie, for the interesting presentation. Just one question regarding the climate change. Is it due to only global warming and greenhouse, or decreasing of the green lands worldwide also could be one of the main factors?
Oh, yes, that's a really good point. Yeah, so deforestation definitely does impact climate change. So yeah, I actually, we'll talk kind of briefly about this later, but essentially, yeah, so plants do need carbon dioxide to grow, and they take away some of the excess carbon dioxide that we put out into the atmosphere. So as forests are taken away, that definitely does contribute to climate change. And it also, I mean, kind of on top of that, if forests are taken away for something like agriculture, that kind of contributes twofold, because agriculture, especially things like cows, they put out a lot of methane. So that kind of increases, that contributes to climate change as well. So that's a really good point.
All right, let me ask one last English questions, and then we'll move to a couple of Arabic questions. Do you think that solar power is enough to replace the regular oil power?
I can take that. I think in terms of quantity, yes. So there is much more solar power that reaches the planet every, day that what we need, even on a year. So there is a huge amount of solar power to collect. But one of the big challenge, of course, is to store that power. So for instance, if you have that solar power and you cap it with solar panels, you need a lot of them. And especially you need storage for, using it in winter, for instance, or using it at night. So that is the bigger challenge. So this is why for now, at least I know the forecast in France, the most realistic forecast, they say that we need solar power, of course, but you need some background of nuclear power if you want to go fully decarbonized to kind of maintain a base state, especially in the short term. Maybe in the long term, technology will evolve and make it very easy to store energy, solar energy. But yeah, for now, it's still useful to have another source of energy, such as nuclear, for instance.
شكرا إيمانويل. كيتي، أنا عارفة إن أنت يعني تطرقتي للموضوع ده خلال بتاعتك، ولكن في سؤال هنا يمكن ممكن نلخص مرة أخرى عشان التوضيح للمشاركين. ما هي الغازات المسببة لتلوث الهواء والاحتباس الحراري؟
Do you mind repeating the question? Actually, I don't think I got that.
Sure. The question. Hold on. I'm gonna do it in English. So the question was asked in Arabic, but it's basically like something that I feel you've gone through your presentation, but maybe to summarize for everyone and just to make it clear, it's about what gases cause the issues that we're seeing today with global warming. What are the gases that are causing this?
Yeah, definitely. And I probably spoke a little quickly through that one, so I can just kind of go back to that slide. Let's see. Yeah. So the big one is carbon dioxide. That's really responsible for about 2/3 of the global warming, well, 3/4 actually, of the global warming we're seeing today. Methane is the next biggest one. So as I mentioned, carbon dioxide is released by the burning of fossil fuels, and as Emmanuel mentioned. And methane is largely methane is released by agriculture, mostly cows. So cows, basically, when they burp and fart, they release methane. And also off-gassing of natural gas development releases methane. So those are kind of the big ones that scientists track.
All right, thank you, Katie. كيف يمكننا كصحفيين الحد من الانبعاثات الغازات؟
So the question is kind of like how you can personally limit your greenhouse gas emissions?
Yeah, I think that's what he's asking. As journalists, like, what can we do?
I see. Yeah, that's a great question. And there's a lot of good resources on this that maybe I can add to the slides after, and we can share them. It's difficult because climate change is such a wide-ranging problem that you kind of need global action, and that tends to come from the national level. So you need things like the Paris Agreement, kind of all the countries agreeing to limit their emissions. But on a personal level, there's small things you can do. Meat does contribute a lot to climate change. So eating less meat, if you're able to, that does help. Things like taking public transit instead of driving a car, reducing your flying, which, I'm currently in Norway, so I'm not doing a good job of that. Yeah, just kind of even just really small things like making sure you're using a little less electricity at home. If you're able to buy an electric car, that helps, that type of thing. Emmanuel, I don't know if you have additional.
Yeah, so I posted in the general chat channel, I posted the link to the Drawdown project. Okay. So this Drawdown project is a website that lists a lot of the actions that are the most effective at reducing carbon pollution. And this is really good resource. So for instance, they explain that the things that we already know, that switching to electricity, and renewable source of energy is one of the best way to limit climate change. And then you have other things that might be more surprising, like allowing women to control their own birth, so that if they don't want to have as many children, they can do it. So that is a solution, maybe, but it's part of that report. But as a journalist, you mentioned, I mean, I guess the best way is to do your job, which is to inform people about the reality that climate change is happening, to explain why we know that it's due to humans. Read that, for instance, the Drawdown project, and explain what is in there to your audience. That's what I think is the journalist's best job to do.
Well, and you just answered actually a question that we just got from Hiba about the role that journalists play in trying to limit climate change. She's asking if you think our job is to change policies. You want to add anything to your answer?
Yeah, no, I mean, the job of scientists and journalists is probably not to change policy, because that is the job of politicians and the society at large. So it's more to inform. Scientists and journalists, in my mind, is to inform people so that they are not misled about the reality of the problem. So first, yeah, really explaining that it's happening, that it's a problem that needs to be fixed, but then it's up to the people and the politicians to more take action on it.
Thank you. I'll take one last question, and then we should probably get back to the presentation. It's from Mahmoud, and it's in Arabic, so I'm going to switch to Arabic and get the translation. دعم الوقود الأحفوري يحدث انقساما بين الإعلاميين في بعض الدول العربية، فبينما يطالب البيئيون بإلغاء الدعم لمكافحة التغيرات المناخية، يرى آخرون أن الوقود الأحفوري ما زال يعتمد عليه كثيرون في تحركاتهم وفي حياتهم، وبالتالي فإن إلغاء الدعم يؤدي إلى زيادة الأعباء على الشعوب الفقيرة. كيف يمكن لنا كإعلاميين في الدول النامية التعامل مع هذا الأمر؟
Yes, so good question. If I'm understanding it correctly, I will say that climate change definitely has a outsized impact on poor countries and just impoverished people as a whole. If you don't have access to air conditioning, for instance, and the heat is just, going, like you mentioned, above 50 degrees Celsius, like that can be a huge health problem. Heat can actually kill people. That's, very concerning. And people with less resources do not have the access to get to cooler spaces when they need to. Things like, flooding in poorer nations, island nations in particular, there's a lot more kind of concerns with sea level rise and flooding, kind of not stable housing. So kind of like low-lying housing that isn't kind of equipped for floods and sea level rise. But yeah, I think I would say as a journalist, kind of as Emmanuel said, the best thing to do is just to report on these topics as much as you can, and make sure that there is accurate information out there, and make sure that people, do know what's going on and what these impacts are. Does that answer the question?
Yeah, I think that it does. Emmanuel, would you like to add anything?
No, I think I'm good. I can just carry on with the presentation if you're fine with that. So up to now, Katie has presented to you some observations about, what we see about the climate, how we see the changes in the sea level, in the ice, in the pole. But now I want to just illustrate the methodology that scientists use when they investigate the cause of global warming. So basically answering the question, how do we know that humans are the cause of this increase in temperature that we are observing at the scale of the planet, right? So on the right side, I remind you about this graph of the temperature. But basically, let's play this game of trying to guess which cause could explain what we observe. And that is really the process that scientists use to know what is true from what is false. So we observe that there is a temperature increase, and the process from scientists is to ask a question, which is, what is the cause of what we observe? What is the cause of this? So there are different hypotheses that are possible. So I put here hypothesis 1, saying it's natural. So the first hypothesis would be, and for scientists, they consider that there is nothing strange with this global warming. It could be just natural. That's just an hypothesis. Another hypothesis that has been put forward and studied by scientists is that it could be the sun which maybe change, and that would cause the climate to change. And the last hypothesis that we can explore in this summary of what explains climate change is hypothesis 3 here, that it's the increased CO2 that explains this increase in temperature. So I just wanted to illustrate how the process of science works in a very simplistic way, in a very simplified way. So below, when you have an hypothesis, the first one that it's natural, the scientist would say, okay, what do we expect to see if this hypothesis is correct? So if it's natural, we are going to observe, for instance, that similar changes happened in the past. Click next, Kelly. Okay, so we have some studies that make observations, and they can be either consistent with this hypothesis or not consistent. Next. So I'm just showing you here one example. It's a study by somebody called Lovejoy, and this study was analyzing whether it is possible that the change in climate that we observe today is natural. And basically what they explain, it's highlighted in blue here, is that the natural warming hypothesis can be ruled out with a confidence level of 99%. So basically what they have done is study the past fluctuation of temperature and see that in the past, it has never happened that climate change as fast as we have today happened. So next. Right, so I put a little red cross here next to these studies, just to show that there is an incompatibility between what we observe and what would be observed if that hypothesis was correct. Next. So giving you just a little bit more details about how we study the climate changes in the past. So basically the scientists, they go and collect samples all around the world. They collect samples in the ocean, at the bottom of the ocean, or they collect samples in the glacier. So all these samples of mud or ice tell you about the temperature in the past. So that is how we are able to say, okay, no, it did not happen naturally, that we had a fast change like the one we are observing, except in the very far past, where we know that there is something else happening in the ice age of the past, for instance. Okay, next. So going back to our exploration of the different hypotheses, basically what we have done by looking at what we can observe in the world is maybe rule out the hypothesis 1, say, we don't think that this is the cause of climate change. So the second hypothesis would be that it could be the sun. So again, we go through the same process. If it is the sun, what do we expect to observe? In that case, we would expect to observe first a change in the sun activity. Next. Okay, and this graph here is showing you in blue the change of the solar energy coming to the Earth versus in red, the temperature change. And as you can see on this graph of the amount of energy coming from the sun, in the blue graph, you see that at the beginning of the period, it was increasing. And now starting in 1960, it started decreasing. So this shows that the amount of energy coming from the sun is actually decreasing. So this is already incompatible with the possibility that the sun activity is changing, and that would explain climate change. Next. So from this observation, again, I put a little red cross here next to the hypothesis that the change might be responsible for the climate change. Another expectation that we would have if the sun explained climate change is that we should see a warming of the entire atmosphere, from the bottom to the top, right? Because the sun would heat the entire atmosphere from the top. And if you click next, Katie, by contrast, if what explains climate change is an increase in the concentration of CO2, carbon dioxide, then we would see something different. We would see a warming at the bottom of the atmosphere and a cooling at the top, basically because we add a blanket to the atmosphere, so it's warming below and it's cooling above. So you see that that's really how the scientists operate. They say if one hypothesis is true, we should observe this. If another hypothesis is true, we should observe something else. And then we go and we observe which one is correct. So click next, please. All right, so this is what we observe now. When we look at the trend, which means the change in temperature throughout the atmosphere. So on this graph that you see on the right, you will see that from the top, which is the top of the atmosphere, to the bottom, which is the surface, and the left to the right is the south hemisphere, to the equator, to the northern hemisphere. So you have like a slice of the atmosphere of the planet, if you want. And on this slice, what you see is the top has a purple color. And this means that over the past 30 years, the top of our atmosphere, where the planes fly, is cooling, right? So it's getting colder up there in the atmosphere. And at the bottom, at the surface, it's getting warmer. So this is consistent with the hypothesis that we are actually observing a change in climate that is due to greenhouse gases, but it's not consistent with the sun explanation. So if you click next, what we see here again is I'm putting a little red cross in front of the warming throughout the atmosphere, because that's not what we observe. And I'm putting a green check in front of the warming low troposphere and cooling upper troposphere. So that is how scientists, say this hypothesis is probably wrong, this hypothesis is probably true. And if we click next, another observation that we should see if CO2 is responsible for climate change is that the temperature increase of the Earth is proportional to a mathematical function called the logarithm of the concentration of CO2. So we predict what we should observe. And this was actually predicted in 1896, so more than 100 years ago. So this is very old, scientific papers. They say this is what we should observe. If we add CO2 in the atmosphere, we should observe a logarithmic relation with temperature. Next. And now here is the data. So you observe here on this graph, each little dot is 1 year since 1859. And on the vertical, you have the temperature anomaly. And on the horizontal, you have the logarithm of CO2. So basically what we observe is a very good relation between the two. So all the dots are aligned, which means that the anomaly of the Earth's temperature is related to the CO2 concentration in the atmosphere. So that is, again, a very strong piece of evidence that the scientists who explained that CO2 is responsible for climate change are correct. So next. With this, we have kind of finished the little game that I wanted to show you to illustrate how scientists think and work on a day-to-day basis. So we had several hypotheses to explain what we observed. And you can see that, we ruled out. We said, okay, the scientists over the years say, it's not the sun, it's not natural. The only hypothesis that is possible based on all the observations that we are seeing on the planet is that it's the humans who are causing climate change. So this is simplified, but it's also to show you the power of the scientific process. And it's only effective when you have a lot of data, a lot of observations that come together in a coherent explanation of what we are observing. So that's why you can't really speak about a fact that is isolated. It's all related. You can't, even when you do fact checking, you have to always understand the whole science that explains everything around that. So if somebody says something different from what the scientists have said over 100 years, you have to be very careful, because you can't overturn a century of science with just one observation. Okay, let's go next. So this is just, again, the figure that I showed before to really make sure that you got that message about the fact that the sun cannot explain current climate change. The irradiance of the sun is going down while the temperature is going up. So it cannot be the sun. Next. And again, the relation between the temperature, which is shown here by the blue and red bars, and the concentration of carbon dioxide, which is the gray line. So you have a good correlation. In itself, it's not enough. This figure is not enough to prove that humans are causing climate change, but the process of science is not to show you just one thing. It's to take all the observation that you can and explain the whole of the observations with coherent, theories and understanding of how things work. Next. And yeah, the last one thing to show you how, extreme the change that is happening now is, because you see that over the past 800,000 years, so almost 1 million years, from data from glaciers, from Antarctica, you can see that the carbon dioxide oscillated. You had ice age and period outside of the ice ages, and you have this oscillation. But right now we are really overshooting. We are entering completely in a new territory with the amount of carbon dioxide that we are reaching in the atmosphere. And we know that this carbon dioxide comes from humans because it has some, composition that is characteristic of fossil fuel. So we really know that humans are the cause of this increase in carbon dioxide. Next. Okay, so I think I will stop here. Again, we have a little bit of time for questions, and then Katie will take it from there for the impacts of climate change.
Thank you very much, Emmanuel. Let's see what questions we have. I'm going to start with a question by Fatima, who is asking, what I know is that we're too late in combating the effects of climate change. Do you think that that's true?
I would say it cannot be true in the sense that we can't say it's either too late or it's okay. The later we wait, the more we wait, the more we get close to being too late, but it's never really too late. Whatever we do now to decrease emission is better than nothing. And of course, it would have been better to change and decrease the amount of emissions in the past, but we can't change the past. So if we decrease emissions now, basically what scientists tell us is that the climate of the planet is going to stabilize. So we have warmed, but if we stop emitting CO2, then we are going to stabilize at the climate that we have today. So today we are still alive, so it's not too late, right? Because if you stop emitting now, that's the climate we get. We already have, so it's too late if you want to avoid every impact of climate change, but it's not too late if you want to make it not as bad as it will be in the future if we keep emitting carbon dioxide.
Thank you, Emmanuel. I'm going to translate this question from Arabic. Are there any plans to expand scientific studies related to this to raise awareness about the dangers of climate change?
Could you repeat? Sorry, I didn't get it.
Sure. It's a question about whether there are more studies. Do you see like an increase in the studies that, you know, talk about this and that would lead to increased awareness about this issue?
So actually, the number of studies on the cause of climate change are decreasing, in the sense that we know once a problem is solved in science, there is not much interest in, you know, studying it again. So the number of studies that try to understand the cause of climate change are decreasing. But now what is increasing are the number of studies that try to understand the impacts of climate change. You know, so this is still a very active field of research. Knowing what exactly climate change will be in terms of impact on drought, impact on precipitation. So this is something Katie will be talking about in the next slide.
Thank you, Emmanuel. A question from Hiba. Are there any scientific efforts to try and reverse the effects of climate change?
Yes, so there are plenty of efforts on that. I mean, there are efforts, as we described before, about inventing new technologies that, you know, provide energy for society without burning fossil fuels. So a lot of studies, which is more engineering, at least what I'm talking about here. And there are also a lot of studies about how this change can happen on a society level, because it's not only a technical problem, it's more now a problem of society. So how do we get people to understand there is a problem that doesn't affect them right now, but that is going to affect all of humanity for millennia to come?
A question about services related to satellite imaging and providing journalists with pictures and videos that would help them in conducting investigative pieces related to the environment.
So I guess maybe we have some resources Katie will present later, and we will be sharing the slides that we are showing you. So a lot of what we are going to show you next, we have links in there. So we are going to send you the presentation as a PDF, and then you can click on all those links. And yeah, then we can keep discussing about these resources after the presentation. I think that would be the most effective.
Sounds good. And a question in Arabic again that I'm going to be translating. It says, for us in the Arab countries and developing countries, the non-industrial countries, the percentages of emissions are minimal if we compare them with industrial countries, which makes this issue of climate change more prominent in industrial countries than it is in developing countries. What are the most prominent ways that climate change appears in our countries, in these developing countries, so that we can focus on them?
So regarding which countries are more responsible, if you want, I think it's true that industrial countries like the USA first and Europe also historically are the countries where most of the emissions have originated. Now, increasingly, the emissions also come from emerging countries, so-called, like China, India, and Russia, for instance. And in the Middle East, I think the situation is very contrasted. I think some countries like Qatar or I think Emirates or Saudi Arabia have a very high emission of CO2 per person. So they are smaller countries, but producing a lot of pollution per person. So yeah, the solution really has to come from every country on the planet, I think, because they all have different challenges. So for instance, the emerging countries might not have emitted emission in the past, but they would probably need to adopt different pathways than Europe or the USA, for instance, so that they don't emit in the future. And they also adopt the new technologies of the future that will grow their economy without polluting as much as the other countries have done in the past.
Thanks, Emmanuel. And I think you've also answered the question that Abdullah had posted earlier about the contributions of some countries, contributing more to the problem than others. We have another question from him about the ways that, I'm just going to read it out loud. True, again, humans, nothing changes their routine, political effects. He's asking for any big suggestion that can be possible to save us. I mean, compulsory rules to make humans stick with it.
Right. I mean, there is no magic solution, right? I don't think there is any one big solution that would solve the entire problem. In my opinion, the only solution is that most people on the planet understand this problem and actually ask their government for solutions. So for instance, there has been an election recently in France. I take this example because I know France, and now more people who vote, they want to vote for people who are going to take action on climate change. So I think this is the kind of initiative that can work on the long term if the population and the government understand that this is a good thing to do on the long term. Then also, as the solutions become cheaper, as the investment in new technologies that don't emit as much CO2 become more efficient, this will be the smart thing to do economically. And that is the time when it will be more cost effective to pollute less than to pollute more.
Thanks, Emmanuel. There's a long question in Arabic, so I'm going to switch and let the translators do it. Just a note to the translators, this is the question from Johanna, so if you want to read it from the Q&A, you can also do that. وظيفة الصحافة والصحفيين هو رفع وعي الجمهور لأهمية دورهن بالتأثير على السياسات ومتخذي القرار بوضع قوانين تقلل وحتى تحد من الصناعات المؤذية للبيئة. الثقافة المشجعة للاستهلاك والتي تؤدي إلى كميات رهيبة من النفايات والتي هي السبب لانبعاثات غازات الدفيئة. إذا رجعنا للمواطنين الإيمان بقدرتهن على التأثير سنكون على الطريق الصحيح. مطلوب انخراط المواطنين بنص قوانين في عدة مجالات تساعدنا على تقليل وتيرة اقتراب أزمة لا رجعة منها. هل العلماء يوافقون هذا الطرح الاجتماعي الحراكي الجماهيري؟
I think what was described in this comment, then question, is kind of what I was describing before, I think. So that is really a social demand that would be the solution to this problem. That's my understanding.
Yeah. And one last question, how are countries going to deal in the case the ice melts?
Okay, so we know that the ice at the poles, for instance, are melting, that the glaciers, most of the glaciers around the planet are also melting. So these are about the impacts of climate change. So now, what are the consequences of that? So what we know from the IPCC, so the International Panel on Climate Change reports, these reports show us that at the end of this century, what we are going to be likely getting is about maximum 1 meter of sea level rise on average on the planet. It doesn't mean that every single place around the planet that is a coastal place will have 1 meter more. Some regions will have more, some regions will have less. But yes, basically it means it's a huge challenge for all the coastal cities around the world. And you have examples of what is happening, for instance, with the Hurricane Sandy in the US, in New York, that happened in 2012, so 10 years ago, where the flooding reached the metro system. So because of sea level rise, the kind of flooding that can happen from a hurricane or for heavy rain events can create this kind of damage on coastal cities. So now how they can adapt, well, this will be costly, so it's important to know it. So the cities try to block as much as they can from the ocean. Some cities put more, sea defense to avoid the waves coming in. Some cities put more, forests along the coast, because that also can be a solution to limit the impact of storms as they come on land. But basically, it's very hard to fight sea level rise. And a city like Miami, for instance, in the US, that is on the shore and that has, sandy soil, the water can infiltrate under. So you can't really protect from the ocean. And these cities basically will have to live with seawater in their streets, right? That's kind of the picture that we will get at the end of the century, very likely. And in that case, it's very hard to adapt. The only kind of solution is to abandon some of the houses on the coast and build more inland. So yeah, sea level rise, I don't think there is a solution except reducing carbon emission now, but otherwise the coastal regions will have to adapt to more flooding.
Thank you very much. I feel like it's a good time to return to the presentation.
Great. We just have a few more slides on kind of the science of climate change, and then we will move on to the fact-checking aspects of this. So we wanted to touch on some major impacts of climate change. One major impact is that climate change can exacerbate extreme events, including heat waves, droughts, and extreme precipitation. It can make these events more extreme, and it can also make these events more likely. Sea level rise, I touched on, and Emmanuel just touched on very well. Health impacts, I mentioned sort of the health impacts that go along with extreme heat. There's also health impacts that go along with changing kind of locations of disease vectors, such as insects. So in North America, a big example is ticks, which can spread Lyme disease and other diseases. As climate changes along the East Coast in particular, ticks are moving farther north. So this is just a big health impact. Different locations that didn't previously deal with certain diseases can now actually be fighting those diseases. Similarly, ecosystems can change, kind of similar to the disease vectors changing their ranges. Different species can change ranges. So that can really put an impact on, fishermen, somebody who, fishes for a living. Maybe the fish are not that they're used to catching are not there anymore. They've moved somewhere else because, the water has gotten too warm for them. We see this in kind of a variety of species, both plants and animals. Crops similarly can be affected if precipitation changes in a location, if there's not enough rain anymore, if a location is seeing, droughts more frequently, that can really impact crops. Actually, excess CO2 in the atmosphere can impact crops in kind of funny ways. It can lead to a decrease in nutrition in some crops. It's kind of an interesting realm of science that we won't get deep into, but there can be a lot of impacts to crops kind of from climate change and from, the excess greenhouse gases that cause it. And as we've mentioned before, just that shrinking glaciers and the declining sea ice are both an impact of climate change. So we also wanted to touch on the specific impacts of climate change in the Middle East and North Africa. And as you recall from that slide a couple of slides ago with the warming planet, the Middle East and kind of Arab nations are particularly vulnerable to climate change. It's actually one of the most vulnerable regions in the world. A recent study found that Iraq in particular, the temperatures there are rising 2 to 7 times faster than global temperatures. And I know, we've mentioned earlier in this presentation, some of these record temperatures you're seeing in some Arab nations, like 50 degrees Celsius, more than 50 degrees Celsius. I think there was a few different in the last year, even just record temperatures hit. So that's going to lead to hotter and drier conditions, particularly in summer where it's already hot and dry. So that just can cause a range of impacts, particularly health impacts, like I've already touched on. Somebody who works outside in particular can be, is going to be very heavily impacted by just extreme heat. It's extremely dangerous. It can cause heat stroke, it can cause death. So that's just an extreme health impact from that. Water scarcity, that kind of ties into health. Obviously, water is critical for survival. And in an already very hot and dry region, water scarcity is something that is, an extreme problem that, climate change is making worse. And then just kind of building off of the health issues, burning fuels such as coal and wood, so even just in your own kind of cook stove, poorer people will use like cook stoves to kind of heat their homes and like make food. That's can bring other health issues, so respiratory problems, lung problems, and it can also exacerbate climate change. So that's kind of adding into those health impacts from climate change.
Can I just add something quickly?
Yeah, of course.
On the previous slides. So that is one thing that I didn't speak before, but I think I should. One question was, what can journalists do about climate change? And I think one of the important things is to explain the connection between health and climate change, because I think for people, it's more personal. So there are two health issues that are interconnected with climate change. One is the fact that as we burn fossil fuels, like coal, wood, but also oil, it has impact on people's health. So breathing the pollution, in many cities, like in India, for instance, they can't even breathe properly in the cities anymore when it's very hot, and they're burning a lot of coal to power their cooling systems, whatever. So, there is both an advantage to decreasing the amount of things we burn because it's causing direct health damage to people, and it's also causing climate change. So that's the first connection between climate change and health. And the second one is, what is described here, which is that climate change has and will have consequences for people's health. So, for instance, by extreme heat, but yeah, there are other aspects as well. So that is an important thing that people might not realize, and that would be important for journalists to explain, I think. That was my short comment.
Yeah, thanks for that. No, that's a really great point. Okay, so I know we had a question earlier about good sources for climate data as you're starting to, fact check climate related claims. This page will show you, or this slide shows you several very trusted sources on climate data. So the first one is the IPCC, which Emmanuel already mentioned. That's the UN body for assessing climate science. The IPCC puts out regular reports. It's kind of summarizing just the wide body of science related to various impacts of various kind of facets of climate change. So impacts, causes, everything related to climate change, the IPCC puts out reports on. So if you have a question related to climate change, it's a very good source of information. We have a few other ones here I'll go through very briefly. Carbon Brief, that is an outlet that does very scientifically sound content on climate change. It does a wide range of content, so including fact checks, but also things like Q&As, just web articles, kind of recent news, that type of thing. So, sometimes if we get a new claim, we kind of see, oh, has Carbon Brief done something on this already? And if so, we kind of can use that as background. The next few are United States government climate sources or climate resources. So NASA has a very good climate page with very accessible climate information, very easy for just the average person to understand. You don't have to be a scientist. NOAA puts out monthly global climate reports. So just, it does the whole world. It goes into kind of extreme events, just, how much the planet has warmed in the last month or cooled. It really just depends. So that's a good source of data. Climate.gov is very good for graphics. So a couple of the graphics I've actually already used have come from Climate.gov. Also very good for frequently asked questions. Again, quite accessible climate data. Snow and Ice Climate Center, that's mostly for frozen parts of the world. So if you're doing a fact check that has anything to do with, Arctic or Antarctic, that can help. And then these next two are just kind of similar to the United States one, but just for different countries. So the UK and Australia. And then our climate science desk from Science Feedback, we're going to get into that towards the end of the presentation, but basically we want you to know that we are a resource for you, Emmanuel and I and the rest of our team. So if you have, climate claims that you're wanting to check, we can help you with them. So we'll explain how that works towards the end. Okay, so my thought is to continue on, since I know we've had a couple question sessions about climate science, unless there's any kind of burning questions right now.
No, I think it's good to keep going to make sure we get through the material, Katie.
Okay, perfect. Yeah, we have several slides, so I'll move through these quickly. So we are going to start talking about climate misinformation and how to fact check it. So very briefly, climate misinformation and disinformation, very similar, obviously, to the misinformation and disinformation you guys are used to, but related to climate. The big kind of thing that purveyors of climate misinformation do is cast doubt on well-supported theories or discredit climate science. So as myself and Emmanuel have discussed already, scientists are they have a strong consensus that climate change is happening and that it's caused by humans. And misinformation tends to kind of try to discredit that consensus in various different ways, which we'll get into. So this slide is just showing kind of how misinformation is really flooding the web and tends to sometimes top actually credible information. It's a little bit older, it's from 2016 to 2017, so take it with a grain of salt. But you can see from this graph, this yournewswire.com is extremely high. Something that says that scientists declare climate change a hoax is extremely high in terms of how many social media shares it's getting. It tops, credible sources like the BBC or the Guardian or the New York Times. The Daily Mail is right below. So scientists manipulated global warming data. So it's really just showing that misinformation is very prevalent in the online ecosystem. And people, I think, don't always know that, what they're sharing is coming from a source of misinformation, essentially. And kind of related to that, the gatekeepers of information, so, things like Google and Facebook are sort of being gamed. So they don't, again, always know, they don't have the resources to say, oh, we're going to make sure we kind of suppress climate misinformation, whereas, good climate information gets more viral, essentially. It really just depends on the users themselves. So as you can kind of see from this graphic, a source of climate misinformation, in this case, coral reef misinformation from Breitbart is shown in Google right alongside some more accurate, more trustworthy sources of information. So as a viewer, or as kind of an average user of these, of Google, you might not know, okay, I don't know that Breitbart is a source of misinformation from sometimes. I don't know that it has published kind of climate contrarian pieces in the past. So as a user, kind of people are getting gamed a bit. And that's part of what we are trying to do. And Emmanuel will talk about this later, but we have, partnerships with these social media platforms that we're able to flag kind of misinformation. So going into climate misinformation in particular, we have 5 main types. The first one is climate change isn't happening. So that's just denying outright that, the scientific consensus of climate change. The second is climate change is happening, but it's not due to humans. That was sort of what Emmanuel mentioned earlier. So, maybe it's due to the sun, or maybe it's just a naturally caused thing. Again, as Emmanuel mentioned, also been debunked. It is happening, but it's not that bad. That type of kind of claim is things like, well, CO2 is good for plants. Plants need CO2, so thus, climate change is fine. Excess CO2 is no big deal. It is happening, but solutions won't work. So, it's climate change is happening, but it's too late to solve it, essentially, which can be a bit of a defeatist sort of attitude, not the thing that we want to kind of portray. And then climate science is unreliable or can't be trusted. That often comes up in things like, models. Climate models can't be trusted. We use climate models a lot. They're actually quite accurate, but a lot of sort of purveyors of misinformation tend to convince people that the climate models we're using are not accurate. And I won't explore this right now, but when you do get these slides, I would recommend clicking on this link here, this computer-assisted classification of contrarian claims about climate change. It has all of these 5 main types, but then it builds them out into smaller subclaims. So it's really fascinating. It almost kind of covers the gamut of smaller subclaims you'll see on the internet. I was going to put it in the slides, but it's a little bit small, the graphic is, so I definitely recommend you clicking on that. Okay, so kind of going along that, we have a few examples of myths here, and those are sort of the subclaims I was talking about. So already mentioned, climate change can be caused by solar activity. We covered that. If you want more information, there's an explanation here from NASA. Definitely click on it. Human influence is too insignificant to cause climate change. We know that's not true. Very briefly, if you guys are familiar with the ozone hole and how human activities cause the ozone hole, we know from that example that humans are significant enough to cause major environmental changes. And then in terms of, as we've already mentioned, with the very large increase in greenhouse gases we've seen in the last several decades, it is definitely humans caused. And then, as I mentioned before, climate model predictions have failed. Models don't match data. I would encourage you to click on this Carbon Brief article. It goes very well into kind of how we know that models are accurate. It has a really good graphic about like how well models have predicted just the last several decades of warming. So definitely look at that if you're interested. I mentioned this before, but CO2 is harmless or beneficial for the Earth. We recently did a larger claim review on that we will talk a little bit about later. But again, we know that CO2 causes climate change, which causes a wide range of very not beneficial, impacts on the Earth. And then climate change is natural, or the climate is always changing. Emmanuel spoke to that earlier, so I won't get too much into that. And then I wanted to also touch on the fact that sometimes misinformation can come from, for lack of a better word, the other side. So even if you are somebody, even if a source is somebody who accepts the scientific consensus on climate change, sometimes the phrasing can be not the most accurate. So for instance, something like climate change caused a specific heat wave or extreme weather event. So saying something like, climate change caused this recent very large hurricane. That's not accurate. That isn't the way scientists kind of study climate change. It's more, climate change made this weather event specific percentage more likely. And it really just depends from weather event to weather event. So if you see somebody saying, climate change caused something, that's not an accurate way of phrasing that. Also not accurate often is climate change has nothing to do with a specific very extreme heat wave or weather event. That really gets into attribution science. You know, as I said before, that tries to explain or tries to dig into how much climate change made a specific weather event more likely. And sometimes it finds that it made, you know, a specific extreme heat wave like many times more likely. So it's definitely climate change is a factor, but we just can't say that it caused it. That's just not the way the science works, essentially. And world weather attribution here, that's a really good resource when writing about extreme events. So if, you know, you have a very extreme heat wave or a very extreme, you know, other sort of event, and you're trying to figure out, you know, how much did climate change contribute? How much do scientists, you know, connect climate change to this event? You can use this resource here. And then very briefly, this is kind of another pitfall that those who do accept the consensus on climate change fall into from time to time, which is focusing on worst case climate scenarios. And we have a little headline down here about scientists explaining what New York Magazine got wrong in a recent, in the last few years, article that kind of had a bit of a doomsday tone to it. And that's not always helpful either, because we don't know exactly how much, you know, emissions will be decreased or increased. It really just depends on how much, you know, the world takes action. So focusing on worst case scenarios is also not helpful. It kind of gives the purveyors of misinformation a bit more fuel, if you will. Okay, so we wanted to really just take this opportunity to introduce science feedback and climate feedback in particular. So basically the concept is there's a lot of misinformation out there when it comes to climate change, and we want the scientists to basically review it and respond to it. We see, you know, a viral article that has to do with climate change, and we reach out to scientists that, you know, are specialized in that topic of that the article covers, and they kind of respond to it. And as you can see here in these two examples, we don't just focus on always kind of inaccurate articles. I would say it's most of what we focus on, but sometimes we will cover an article that is going viral, that's very popular on social media, but it actually ends up being accurate according to scientists. So it's really just anything that's kind of making a really big, I guess, splash on the web. We will fact check. And yeah, kind of our goal with it is to, for the public, is to show people kind of where they can go for trustworthy sources of information. So if we, you know, are seeing that a certain outlet is getting a lot of inaccurate reviews from us, our hope is that the public will notice that and kind of act accordingly. Also, for journalists and editors, we want them to improve the accuracy of their coverage. So if we do find that something is inaccurate in a article or in a claim, we do reach out to the editors and the journalists and let them know. We share a link to our fact check, and that way they can see that, okay, you know, XYZ scientists responded to my article and they do not agree with my conclusions, and our hope is that they will correct it, and often they will. And then for Google and Facebook, Emmanuel will talk about Facebook, our partnership with Facebook, a little bit later, but it's also to assess information credibility. So when we do have a fact check that finds that, you know, this viral article, this viral post was inaccurate, we're able to flag that, and then the people who share it are actually able to see that it's inaccurate, and then the people who see the post afterwards are able to see it. But again, Emmanuel will get into that a little later if you have questions about that. Okay, so very briefly, our workflow. We monitor news. We have a few tools, but we also just use social media itself. And we see, okay, like there's a viral article related to climate change, and I think we're going to fact check it. So we decide to fact check it. We work to understand the claim, and then we invite experts to review it. We'll kind of go through the whole steps later, but the experts just need to be specialized in the claim itself. So not just a broad climate scientist usually, but a specialized climate scientist that kind of works on that specific claim, essentially. We then aggregate, the scientist provides feedback. We aggregate that feedback. We summarize it into an article. We then get at least one other science editor at Science Feedback to challenge it. So review it, read through it, let us know if anything just doesn't sound good, if it just kind of is like raising red flags for them. It's kind of our peer review process. And also it's just an editing process. So if anything, you know, doesn't read as accessible or understandable. And then we publish it online. We share it with our social partners, and we share it on our social networks. And then it usually is shared also with the outlet that kind of published the original claim. So probably similar to your work, just in a climate-focused segment. Okay, so this is our community of contributors. This is our community of scientists is really makes the kind of engine of science feedback. We have 500 scientists that are a part of our community. Most of those, I think about 400, are climate scientists. The rest are health. So we also fact check health reviews or health claims, which has been very busy with coronavirus in the last few years. Any scientist can apply to be in our community. They just have to have a PhD in a relevant discipline. They have to be actively publishing on that discipline. So, you know, if they haven't published in like 5 years, we might not be as keen to let them in. And this community is where we go to essentially fact check our claims. So if we have a claim we need to fact check, we reach out to, you know, 1 to 5 or however many scientists we need in our community who can respond. And, you know, depending on how many responses we get, we'll include, you know, 2 or 10 in our review. But yeah, you can see here, we have a few examples. Not the most diverse subset. Unfortunately, all the A's are mostly male, but we definitely try to strive for diversity also in our community. But yeah, that's our community of scientists. I think Emmanuel.
Yep, I can take it over from there. So as Katie has shown to you in our work on a day-to-day basis, we ask scientists to provide a rating of the scientific credibility of, you know, claims or entire article that make a lot of claims. And we ask them to rate it on this scale that you see on the right, the scientific credibility scale. So it's just a number, you know, from very high to very low. And we ask them to look at these 6 dimensions. So that can be also helpful for you when you look at some you know, claim or article covering climate. So for instance, the first, of course, is the factual accuracy. So whether the facts are, you know, true in the reporting, but that is usually not enough to make an article credible. Another one is to have the correct explanation of the science. So that is what I explained at the beginning of the workshop. So, you know, the proper explanation about what we observe in the world. And then the reporting also has to follow sound logic. So we are going to show you examples in the future about problems that can go with these 6 you know, dimensions of the credibility. Another aspect is the precision of language. When you speak about science, you have to be precise about what you're referring to. So sometimes the misinformation comes from not using the right terms. And one very important part is the credibility of the sources that, you know, the journalists would use in their reporting. So for instance, whether the scientists that are used as experts are actually experts in what they are talking about. Again, we are going to show you some tips about how to spot that credibility later. And finally, the notion of objectivity. So the absence of bias in the reporting. And so that is for articles. And when we cover, next, Katie, when we cover claims, we follow the same credibility scale that you see on the right, but we add a little tag as illustrated here. So each of these levels have different tags. So for instance, lacks context or imprecise for the neutral category, all the way to inaccurate or incorrect to the very low category. Next.
Okay.
I want to take it over.
Yes, yeah, I'll take that. Sorry about that. Slow to unmute. I want to get through this walkthrough of the claim review, and then we can stop for questions. I know this is a lot of content. I know we're coming up kind of on time, so we might skip through some of the future slides after questions, but this walkthrough I think will be important. So we wanted to just give you a short walkthrough of kind of how we fact check a claim. And this one we included, it is kind of pretty recent. We fact checked it in November of last year. And it is a pretty simple one, which is partially why we chose it. Mostly just one claim, a pretty easy one to fact check. But the kind of gist of it is that a author at the Daily Wire, which is an outlet that has, it's a conservative news outlet in the United States. It has kind of been a purveyor of climate misinformation in the past, claimed that the Great Barrier Reef is growing quickly. So we saw that claim on social media, and we thought, that kind of flies in the face of what scientists have been showing us about the Great Barrier Reef and coral reefs in general over the last, several years, which is that they're kind of doing poorly in response to climate change. So we wanted to fact check this. So step one for us always is just understand the claim. We want to understand where the source of the claim is pulling their information from. So is that source legitimate? In this case, the source of the claim itself was an Australian government report on Great Barrier Reef health. So the answer is yes, the source of the claim was legitimate. And then we want to go through and say, how many claims are there? In this case, there was really just one. It was kind of a two-part. There was a kind of a smaller claim in there, which I'll get into, but it was really just one, and that is that the Great Barrier Reef was growing. And then we want to kind of look into the source of the claim, the writer of the article, and their background. So I mentioned before, the Daily Wire is a conservative news outlet. It has kind of shared climate misinformation in the past. So we're walking into this kind of understanding that. It does help to know whether the outlet is, funded by pro-fossil fuel interests. We do have some resources on that we'll get into later that can help you with that. But in this case, I don't know of the Daily Wire's funding, but we just know that it has kind of shared climate misinformation in the past. And then did a non-climate scientist write the article or blog post? In this case, yes, but it was a journalist. So, that's going to happen. But sometimes a non-climate scientist will sort of pose as a climate expert, and then that will kind of help you understand the claim. So step two is to find scientists who can respond. So once I read into the claim, understood where it was coming from in that Australian government report, we reached out to scientists who were well-versed in that subject matter. So in this case, it was coral health and the Great Barrier Reef in particular. So usually what we'll do is we'll look through their recent publications in order to gauge the fit. So, maybe someone is like an ocean scientist, but they don't really do much on coral reefs. Like that person we wouldn't reach out to, obviously. But we really wanted to target people who were very well versed in just coral health, how it was impacted by climate change, and the Great Barrier Reef in particular. So I have a little example here. Terry Hughes was one of the people we reached out to. He had many recent coral reef publications, very kind of well-versed in coral reef science. Okay, and then let's see. Another thing you can do is kind of look at kind of a tip, kind of look at Google News. So you can type in something like coral reef health, and you can sometimes find scientists through just like news articles who have spoken recently about that topic. A good thing to do after that would just be to double check that the scientist is legitimate, see if they're from a legitimate organization, that type of thing. And then look at the basis of the claim. So in this case, it was a report from the Australian government, which I mentioned before. And one of the things we could have done, we actually didn't do, we didn't have a whole lot of time for this claim, but one of the things we could have done was to reach out to the writers of the report for experts to contact. That's always a very good thing to do. If you see that a source is pulling from a study that does look legitimate, or even if it doesn't look legitimate, reaching out to the authors of that study or report for response is really beneficial. So step 3, just contact the scientists. Include the claims from the article that you want them to respond to. Usually we just write these out briefly in kind of bullet points. Note that we don't say things like prove these claims false, etc. We just want a response on the claims, and that's probably something you guys understand as well as fact checkers of other topics. But for us, some of the claims on climate change, they sometimes do have an element to accuracy. Sometimes part of a claim will actually be accurate and part of it, won't be, or maybe it's accurate technically, but it's, an example of cherry picking and, or just, you want to just make sure you're not guiding the scientists in what you want them to say. You just want them to respond, to give their feedback. As I said before, contact the scientists who wrote the study that the claim comes from. And a good tip is contact several scientists because not all will respond. And usually you're working on a fairly tight deadline with these. We usually, want to get up the article within a few days because you want to be kind of on that news cycle. So contacting as many as you can is always a good practice. So I put step 4 as research. You can certainly swap that with step 3. I usually contact scientists first because, again, they're really busy and sometimes they just don't have a lot of time. And so I want to give them as much time as possible, but you can certainly research before you contact scientists. So find studies that address this claim, including studies if you do get scientist responses already. Try to find studies that back up the scientist responses. And that is something we will ask scientists in our email to them. If they have a response, could they provide kind of footnotes to that response? Could they provide studies that really just back up what they're saying? And often they will. Often the studies will be their own studies. So they kind of know how to do that. Include those studies in your fact check that you write up. And another tip is just to ask scientists if they don't, include any in their initial email, ask them if they could recommend any to you. Any studies that just relate to this topic that back up what they're saying, that type of thing. And similarly to what I said before, look at recent news coverage from reliable sources for studies. Outlets like Science Daily, which kind of cover really recent studies in the environmental field, are really helpful for that. But just kind of look for research that's been done on this claim and include it in your fact check. And I will note also that places like Carbon Brief are good for that too. And then step 5 is just to write the review, include scientist feedback and your own research, include citations. That's what we do. We kind of, for each statement we make, we include the links and citations to relevant studies, and then we publish the review. And then step 6 would be to update the article if the outlet issues a correction. In this case, they did. So we found that their claim that the Great Barrier Reef is actually growing was misleading. The Great Barrier Reef is actually not growing. There was just an increase of coral cover from year to year, but there's various kind of reasons for that increase that you can most definitely read the article to understand, but it is not accurate to say that it is growing and thus climate change is not affecting the Great Barrier Reef. So yeah, in this case, the Daily Wire did issue a correction. And so we updated the article to reflect that correction. Okay, Emmanuel, do you want to speak on this briefly and then maybe we can take questions?
Yes, so maybe the last one thing to speak about our work at Science Feedback. It's just one slide here. After that, we have 2 slides that I want to show you because there are some advices that we think can be useful for reporters. So this last one thing about Science Feedback is the fact that we are a signatory of the International Fact-Checking Network Code of Principles. So there are about 200 organizations in the world that sign this code. And this is a required condition to work with platforms such as Facebook. So we are working in partnership with Facebook. And what Facebook does with the partnership is that they show us simply, all the news that are viral on Facebook. So one of the criteria that we use to select stories to check is, for instance, if they are viral on Facebook. And if they are, then we write our investigation. We determine if the information is false or misleading or just missing context. And then we communicate that information to Facebook. And they display this notification that you can see on the right side of the screen. So here was a video from YouTube that claimed to destroy climate science in 8 minutes. And there is an overlay here that on Facebook that says this is false information. So I know there are other fact-checking organizations in the Middle East and North Africa region. So yeah, of course, it's the Arabic fact-checking network that can tell you more about who they are. And they might also be partners with Facebook and do this kind of work. So this is what Facebook does, showing a notification to the user, sending them a notification if they have shared a false information in the past, and also decreasing the virality. So decreasing the amount of people who are going to see this piece of information. So that was just, a very quick introduction about the kind of work we do. We also work with TikTok. So, this platform where viral video are uploaded and exchanged. And so we check also misinformation there, but it's mostly about health. So a lot of information there. Misinformation is about COVID, the vaccines, these kind of things. So let's jump to the last 2 slides. Katie, if you want, the potential pitfalls. So then we save some time for the questions.
Okay, perfect. Yeah. So we do have several slides and we're running up on time. So we'll just kind of touch on this briefly. We wanted to talk about potential pitfalls when you're reporting on science. Some of these are kind of making sure you don't engage in the same mistakes that maybe people that purvey science misinformation engage in. So one would be over concluding from anecdotes versus using anecdotes to illustrate a broader issue. We have an example here that you can click on your own, but you just want to be cautious of cherry picking in your own work. You don't want to just pick and choose maybe the one study that shows something that you want to prove, essentially. That's kind of what these purveyors of misinformation do. And really the main way of avoiding that is just to talk to scientists. So they'll say, they will know what the background of the science is. They will know really what, if there is a consensus, what the consensus is, or at least where the field is going in terms of knowledge on a certain issue. So that's really the main way of, avoiding that type of thing. The second is a single study usually doesn't revolutionize an entire field. We have an example for ivermectin. You might be familiar with the ivermectin sort of, not scandal, but kind of news item in the last year or two. It was, one study showed that ivermectin, which is this deworming medication, was shown to be beneficial against COVID. That was not true. The vast majority of other studies did not find that. This was just one study that had some kind of issues with its methodology. It was not a reliable study. So just making sure you are finding studies that kind of uphold the kind of consensus, or if not consensus, the trajectory of the field. And again, scientists will be very helpful in kind of helping you understand that. And I should note that the science desk will also be helpful. We will be helpful ourselves, which we'll talk about later. Third, some misleading claims have an element of accuracy to them. So I mentioned this very briefly. Things like a really good example is, CO2 is good for plants. Well, CO2 is good for plants. That is accurate. Like, saying that is an accurate statement. Plants do need CO2 to thrive, usually, or to grow. Usually that statement is then followed in climate misinformation circles by, therefore CO2 is fine. We don't have to worry about it. Climate change isn't a thing. That's where it gets, not accurate. But you want to make sure that you're reading the claims carefully and making sure that the scientists respond to the claims carefully as well, because you don't want to say something like, no, that's false. CO2 is not good for plants, because then you're kind of also engaging in misinformation. So scientists specialize is the fourth tip. They don't speak about everything. So a kind of a pitfall you might fall into is, maybe you get a claim about hurricanes and you reach out to a scientist who maybe is more focused on coral reef health. If that scientist has something to say about hurricanes, they might not be the best source for you, because usually scientists will say, that's out of my field, I don't speak to that, but they might say, here is someone who could speak to it. So you just want to make sure you're finding scientists who are very specialized. I mentioned before in the coral reef review, people that really get the subject that you're fact checking. And then the last is just the challenge between being perfect and being fast enough to respond to the claim. So it's always, with a claim, with fact checking, it always feels like you could do more. You could dig more deeply into the topic. You could, just make sure to find every element of the claim and fact check it. But usually you're trying to balance that with being quick enough to kind of keep up with the viral nature of the claim and actually have, it be flagged by the different social media platforms. So you want to make sure you're accurate. You want to make sure that you get as many scientists as you can to respond, but you don't have to be perfect in that you address every single aspect of what they say. And yeah, so we'll skip to talking about the climate science desk. And apologies, I'm just going to go through this briefly. If we had more time, we would talk about this. This is helpful resources. You can kind of explain, or sorry, you can kind of explore this on your own. Very helpful. Okay. So the climate science desk, we actually just launched it in the last month. We're very new, very excited about it. Our goal is to help journalists and fact checkers like yourself verify the veracity of climate science related claims for their reporting. So if you have a claim that's climate related, and you reach out to us, we will help you with it. Essentially, we will respond, we'll send you background about the claim. Often, you know, if you send us a claim, it's likely we've written about it before. If we haven't, we'll find background from other sources and send it to you. And then we'll put you in touch with a scientist. So we can reach out to one of our scientist community members and ask them if they can respond to this claim for you. Again, like, if you're more comfortable with reaching out to the scientist yourself, we can always suggest a scientist, but we're happy to kind of make that connection for you. And our goal with this is really to increase the number of organizations that are tackling climate change in their work, and also to expand those organizations that already tackle it, expand their climate coverage. So we just want to help as many fact-checking organizations as we can. So if you want to submit a request, the information is here at the bottom of this slide. You can submit it via email. That's probably the easiest way for now. We have a web interface too. The link is right here. You just need to have a little bit of information about the claim, about yourself, what you're hoping to get. And then you can join our Slack channel. If you are part of the IFCN Slack, you can send me a DM and I will add you. Or you can email me and I should be able to add you via email. And yeah, we will stop there and just take questions since we ran out of time.
Thank you so much, Katie and Emmanuel. This was a lot of very important information, and we've gotten a lot of comments in Arabic on the chat on how useful and helpful this is for the participants. So thank you a lot. We have some of the questions on here you've actually answered through your presentation. So I'm going to try to ask the ones that have not been answered. There's a couple about, verifying, like working on those claims. So a question from Hiba says, what makes you suspect a certain claim or article that you feel the need to check, other than getting them sent to you by journalists?
So as we described briefly before, one of the main criteria we use is the virality. So the fact that the claim is really getting a lot of interaction on social media. So it can be a video with a lot of views, can be an article with a lot of shares on Facebook, on Twitter. So that's the number one criteria. Or if it comes from a prominent source. So we are, in the English-speaking market. So if it comes from a website that has a lot of followers, like the New York Times, these kind of things, that is the criteria. So the influence of the claim. And then we also look at whether it's verifiable, because a lot of the things that are being said on climate are not something that we can check. For instance, a lot of the questions we have received in this chat is about, what should we do to fix climate change? And a lot of that is not really about science. It's about politics. It's about, what we do on a day-to-day. So we stick to the things that we can check from a scientific perspective. So really more, what is causing climate change, what consequences from climate change. So that's what we stick to mostly.
Thanks, Emmanuel. We have a question from Ali in northeast Syria. He says that people over there depend on thousands of generators for electricity, in addition to using primitive oil refineries, which have an impact on their health. So his question is about how journalists could get financial support, grants maybe, to advocate for safe power sources. Do you have any tips on what journalists can do to get some financial support to do reporting on such issues?
Honestly, for the sources of funding, I think it's safer to say that we don't know. I mean, at least for me, I don't really know where people can look. But Katie, do you have some suggestions? I mean, we know more the American context than the European one.
Yeah, I'm not totally sure about sources of funding. You could check maybe Pointer. They might have a list of grants somewhere, because they kind of cover all things journalism, but you could maybe check like things like Columbia Journalism Review, that type of thing. But yeah, sorry about that. I'm not sure.
Thank you. And I feel like at Arij, we might also have some resources or some advice with regards to finding grants to cover certain types of stories. So, you know, feel free to contact us and we'll try to guide you when it comes to this. Question about how the procedure that you use to work on claims by non-scientific sources versus claims by a scientific source. Is it different or is it the same?
Yeah, so I responded in the chat already, but and what I said is that sometimes isolated scientists can also spread misinformation. So that can be the case in climate with, you know, scientists who might not be actually studying climate science or hurricanes. And when they speak about hurricanes, but they are not experts on this, they might get it wrong because they might be expert on something else. And that is also something we realize on COVID is happening a lot. So sometimes people are doctors, or at least they look like scientists. They, you know, they even dress like scientists and make videos on internet. But very often what we realize is the ones who spread misinformation, they speak about things that they are not an expert about. So they speak about ivermectin and COVID, but they are not virologists, or they don't really know about this topic. So they might be just a doctor who is trying to take care of people on a day-to-day basis. So yeah, we address, you know, the claims wherever they come from with the same methodology. And yes, sometimes misinformation comes from scientists or people who look like scientists.
Thank you so much, Katie and Emmanuel. This was invaluable, and thank you for all the work that you do. And we'd love to have you again and hear more about this. I'm going to switch to Arabic. عاوزة أشكركم جميعا على حضور الجلسة دي، نتمنى أنها كانت مفيدة لكم. سيتم مشاركة المادة التدريبية وفيها جميع اللينكات وجميع الروابط وكل الأشياء اللي اتكلموا عليها هتكون موجودة وهيتم إرسالها إليكم. أتمنى أنكم تكونوا استفدتوا من الجلسة دي وأشكركم على أسئلتكم. إحنا آسفين إن ما قدرناش نجاوب على كل الأسئلة، ونراكم على خير إن شاء الله في جلسات أخرى.